Scientists and engineers aren't just planning another mission to the moon. They're designing entire cities where humans could live for months or even years at a time. These aren't small outposts with a few modules and supplies. These are full-scale lunar settlements, built to sustain life in one of the harshest environments imaginable. Within the next few decades, space agencies and private companies envision cities with habitats, laboratories, energy systems, and transport networks that allow people to work, live, and explore on the moon itself. From domed living quarters to underground research tunnels, these lunar cities could transform what was once the realm of science fiction into a practical, functioning human settlement. The moon is no longer just a destination. It may soon be home. The motivation for building cities on the moon is both practical and visionary. The moon offers a unique platform for scientific research, from studying the effects of low gravity on the human body to analyzing the lunar surface for clues about the formation of the solar system. It could also serve as a base for mining valuable resources such as helium-3, a rare isotope that could one day fuel clean nuclear fusion on Earth, or water ice that can be converted into drinking water, oxygen, or even rocket fuel. Lunar cities would reduce reliance on Earth for resources, enabling long-term space exploration without constant resupply missions. Historically, lunar exploration began with the Apollo missions, which provided brief visits and valuable data. But those short trips were not enough to establish permanent human presence. Creating a city on the moon requires careful planning, advanced infrastructure, and life support systems capable of maintaining human life in an environment with no atmosphere. Extreme temperatures ranging from minus 173 degrees Celsius to 127 degrees Celsius, and constant exposure to cosmic and solar radiation. To make permanent lunar habitation possible, cities must be engineered with advanced habitats, energy systems, and sustainable resource management, effectively turning the moon into a livable, self-sufficient environment. Several space agencies and private companies are leading the effort to build human settlements on the moon, each with slightly different goals and timelines. NASA, through its Artemis program, aims to return astronauts to the lunar surface by the mid-2020s and eventually establish a sustainable base at the lunar South Pole. This base would serve as a research hub, a staging point for deep space exploration, and a model for longer-term habitation. Similarly, the European Space Agency, ESA, is exploring concepts for lunar research stations, focusing on scientific experiments, resource extraction, and international cooperation. China's space program, led by the China National Space Administration, CNSA, is pursuing a more ambitious timeline for a permanent lunar base. The plan involves robotic missions in the 2020s to scout suitable locations, followed by manned stations and research facilities in the 2030s. Private aerospace companies are also playing a critical role in making lunar cities feasible. SpaceX, for instance, is developing the Starship spacecraft, designed for transporting humans and cargo to the moon and Mars. Blue Origin is exploring reusable lunar landers and inflatable habitats that could support long-term human presence. Together, these organizations represent a combination of government planning, international collaboration, and commercial innovation, pushing humanity closer to a permanent presence on the moon. Living on the moon presents extreme challenges, and moon cities must overcome environmental, logistical, and technological obstacles. Habitats will need to provide life support, including oxygen generation, water recycling, and temperature regulation to handle the moon's drastic day-night cycles, where temperatures swing from minus 173 degrees Celsius at night to 127 degrees Celsius during the day. Many proposed designs use underground lava tubes or heavily shielded domes to protect against cosmic and solar radiation, micrometeorites, and temperature extremes. Inflatable modules combined with thick shielding layers of lunar regolith, moon soil, are being considered for both temporary and permanent habitats. Energy is another critical concern. Solar panels are ideal because the moon has long periods of sunlight at its poles, but small nuclear reactors are also being considered for continuous energy supply during the 2-week-long lunar nights. Transportation within these cities would rely on lunar rovers for surface mobility, robotic supply systems, and eventually orbital transport shuttles that connect habitats to orbiting stations. Water and essential resources would come from ice deposits at the lunar poles, while oxygen could be extracted from lunar minerals. The integration of energy, water, habitat, and transport systems is crucial, as any disruption could threaten the survival of residents. These technologies aim not only to sustain life, but also to create a platform for scientific research, resource utilization, and future expansion to Mars and beyond. One of the main drivers for building moon cities is the scientific and economic potential of the lunar surface. The moon holds resources that could be critical for future space exploration. For instance, helium-3, a rare isotope found in lunar soil, could one day be used as fuel for nuclear fusion, providing a virtually limitless source of clean energy on Earth. Water ice discovered in permanently shadowed craters near the lunar poles is another invaluable resource. It can be split into hydrogen and oxygen, supplying both breathable air and rocket fuel, which could dramatically reduce the cost and frequency of supply emissions from Earth. In addition to resource extraction, moon cities will act as research hubs. Scientists could study low-gravity effects on humans, test agricultural systems for space environments, and monitor cosmic phenomena with unprecedented clarity. The moon's thin atmosphere makes it an ideal location for telescopes and astronomical instruments, far from Earth's light pollution. Lunar settlements will also serve as testing grounds for technologies and strategies required for missions to Mars and other deep space destinations, effectively becoming the proving grounds for humanity's long-term survival in space. Building cities on the moon comes with enormous challenges. The environment is extremely hostile. Temperatures fluctuate between -173 degrees Celsius during lunar night and 127 degrees Celsius during lunar day, while radiation from the sun and cosmic rays poses serious health risks. Micrometeorites can strike at high speeds, and the moon's low gravity, just 1/6 of Earth's, affects human physiology, leading to muscle and bone loss over time. Habitats must be airtight, radiation-shielded, and capable of providing life support systems that work reliably for months or years. Psychological and social challenges also loom large. Living in confined spaces, isolated from Earth, with limited human interaction, will test the mental resilience of astronauts and settlers. Logistically, transporting materials, building infrastructure, and maintaining energy, water, and oxygen supplies on a distant celestial body is a monumental task. Every system must be redundant and fail-safe, because any critical failure could be catastrophic. Financially, lunar cities will require tens of billions of dollars in investment, international cooperation, and years of testing before even the first permanent structures can be safely inhabited. These hurdles make the moon one of the most extreme places humans have ever attempted to settle. The development of moon cities is expected to happen in stages over the next few decades. NASA's Artemis program plans to return humans to the lunar surface by the mid-2020s, with initial missions focusing on establishing small outposts and testing life support and habitat technologies. These first missions will likely be temporary, with crews rotating in and out, but they will provide critical experience for living and working on the moon. By the 2030s, NASA aims to build a sustainable lunar base at the moon's south pole, capable of supporting longer stays, producing oxygen and water from local resources, and serving as a hub for scientific research and technology testing. China's space program, led by the CNSA, is pursuing a similar timeline with robotic missions in the 2020s to map and survey lunar sites. Their goal is to develop a permanent research station in the 2030s, potentially supporting international collaboration. Private companies like SpaceX and Blue Origin are accelerating this timeline by focusing on transport and habitat technologies that could support permanent settlements. Some experts predict that by the 2040s, international lunar cities could exist with fully functioning habitats, energy systems, and resource processing capabilities, acting as stepping stones for Mars and deep space exploration. These timelines show a clear progression from short-term missions to permanent human presence, making moon cities a real possibility within the next few decades. Moon cities represent a bold leap for humanity, turning the moon from a distant object in the sky into a potential home and workplace. These settlements will be more than just habitats. They are laboratories, resource hubs, and stepping stones for further space exploration. By combining advanced life support systems, energy generation, and resource utilization with scientific research and human ingenuity, lunar cities could become the first truly self-sustaining human settlements beyond Earth. As space agencies and private companies continue to develop these plans, the dream of living on the moon moves closer to reality. These cities could fundamentally change how we explore the solar system, provide new resources for life on Earth, and serve as a blueprint for sustainable human settlements on other planets. Humanity is on the brink of becoming a multiplanetary species, and the moon cities of the future will be our first foothold in the cosmos.